Three things changed at once. Robots are learning from human video, motion models are getting genuinely multimodal, and avatar generation is starting to copy behavior, not just appearance. That matters because the bottleneck is no longer raw model size, it's whether systems can absorb the right kind of supervision and turn it into control, timing, and identity. The common thread here is scale plus alignment. Bigger data, richer conditioning, and much better handling of noise. In the next few minutes, you'll see how that shift is showing up in robotics, human motion, and production avatar systems. Let's explore the first paper, ACE Ego Zero, Unifying Egocentric Human and Robotic Data for VLA Pre-Training. ACE Ego Zero from ACE Robotics with CUHK MM Lab and collaborators at CUHK Shenzhen, SJTU, and THU is a vision language action pre-training framework that unifies egocentric human video and multi-embodiment robot data by converting raw human footage into robot format pseudo-actions, projecting both sources into a shared camera space action representation, conditioning the policy with morphology tokens derived from URDFs or learned human surrogates, and aligning temporal supervision by physical duration instead of frame count. The method also introduces a reliability-aware objective that treats noisy human pseudo-actions as auxiliary supervision, emphasizing high-confidence position channels while downweighting unstable rotation and gripper labels. Instantiated on a 6 0K plus hour mixed corpus, including 4 53K plus hours of robot and simulation data plus 1 48K hours of pseudo-action labeled egocentric human video, and trained with Quen 3 VL 4B Instruct plus a 600M flow matching action expert. ACE Ego Zero reaches 72.8% on RoboCasa GR1 tabletop, 91.12% on RoboTwin 2 easy, 90.62% on RoboTwin 2 hard, and 78.3% on a real ARX bimanual platform, outperforming Pi 0.5 and GR00T N17. Ablations show that removing human auxiliary reliability weighting causes the largest drop from 72.8% to 69.2%, confirming that scale alone is not enough without label quality control. Let's explore the second paper, Any Mo Scaling, Any Modality, Conditional Motion Generation with Masked Modeling. Any Mo, from researchers at the Chinese Academy of Sciences and independent collaborators, tackles conditional human motion generation with a masked modeling design that scales to arbitrary combinations of text, speech, music, and trajectory inputs. Its foundation is OmniHumo, a new web video-derived dataset with over 5,000 hours and 3.2 million motion sequences, each paired with text and a subset of about 500 hours also aligned with audio. The model replaces single-stream tokenization with a 4-layer, residual FSQ tokenizer using 2048 codes per layer, then trains a llama-based bidirectional transformer with parallel masked prediction across residual token streams. This lets AnyMo model global temporal context while conditioning on multiple modalities in a shared embedding space. On OmniHumo text, scaling the model from 111M to 3B parameters steadily improves FID from 262.1 to 55.59 and raises R precision top 1 from 0.63 to 0.75. In multimodal conditioning, adding trajectory input cuts text-guided average trajectory error from 50.5 centimeters to 27.16 centimeters and lowers the share of errors above 50 centimeters from 0.52 to 0.33. The tokenizer also benefits from scale. Reconstruction MP-JPE drops from 94.55 millimeters at 0.5M data to 27.92 millimeters at 3M. Overall, the paper argues that large-scale multimodal alignment, not just larger models, is the key driver of flexible motion synthesis. Let's explore the third paper, Avatar 5 Scaling Video Reference Avatar Video Generation. Avatar V from Heigen Research is a production-scale video reference avatar generator that replaces single image identity conditioning with full reference video conditioning, so it can reproduce not only appearance, but also behavioral traits such as talking rhythm, micro-expressions, and gestural style. Its core diffusion transformer uses sparse reference attention to make reference conditioning scale almost linearly with reference length, while a dedicated motion stream closes the loop between motion prediction and generation, and an identity-aware super-resolution refiner restores facial detail at 1080p. The system is trained on a data engine that mines 50M raw videos into 100M plus pre-training clips and 10M plus avatar fine-tuning clips, then optimized through a 5-stage pipeline: text to video pre-training, audio to video pre-training, personality supervised fine-tuning, two-phase distillation for over 10 times acceleration, and RLHF alignment. At inference, Avatar 5 runs in 24 denoising steps, supports chunk-based generation for unlimited duration, and uses custom compiler, NVSHMEM, and infrastructure optimizations that cut latency by 3 times over the unoptimized baseline and by 33% over Torch.com pile inductor. On a 7.0 case crossing benchmark, it outperforms systems including CDance 2, Kling O3 Pro, VO 3.1, and OmniHuman 1.5, reaching the best SyncNet confidence at 8.97, the best phase similarity at 0.84, and the highest human MOS for identity at 4.98 out of 5, while its Avatar Turing test shows annotators still identify real footage correctly, 77.8% of the time. That's a wrap on today's AI paper highlights. Thanks for watching.